Okay, so for this question, we've got another area. We got to find the area of a region. But here, notice we've got three constraints. We've got that parabola, we get that linear function, and we've got the x-axis, right? Y equals 0 is the x-axis. So what I did, and you could certainly put those into Desmos and graph those areas if you're having a hard time with that, because I mean, this is about, yeah, I want you to be able to graph, but I also want you to be able to do the calculus. So what I did here is I did do this on paper, and you'll see my scalings was weird, but I really did the scaling just to get that linear function. And then I graphed in the parabola, that part of the parabola, and then the x-axis, and then I shaded that in to make sure that I was finding the correct area. Now, what's different about this is I'm hoping you're noticing that it's not the same function. So from 0 until whatever that number is, we're using the parabola, and then from that whatever that number is to where that line intersects the x-axis, we're using the line. So we're going to have to write two integrals, and I do have to find those points of intersection. Now, what I did is to find, I knew 0, 0 was that left end, right? Because when x equals 0, y equals 0, and when y equals 0, x equals 3. So I knew that was the left end. But finding that intersection, and obviously my graph is wrong, I set those two functions equal, and I brought everything over to one side because it's a quadratic equation. I factored out a 2 to make my factoring easier. And then what multiplies give me x squared, 2x squared, 2x and x. What multiplies give me, and you guys know how to factor. So when's this equal to 0? Negative 3 halves. And at 1, negative 3 halves isn't in the range that I want. So I discarded that. So x equals 1 is when I change functions, okay? So then I'm going to write the integral 0 to 1 of 4x squared dx plus from 1 to 3 of the linear function dx. Okay, and of course, the antiderivatives are fairly straightforward. Add 1 to make it 3, divide by 3, and I evaluated it from 0 to 1, and I got 4/3. Then for the linear function, I found the antiderivative, evaluated it from 1 to 3, and I got 4. And so now I'm going to add those two areas together. 4/3 plus 4 became 16/3. And you see that was right. So in a nutshell, decide which function you're dealing with and what region you want. And you're going to decide where to break the integrals. Okay. I would be remiss if I didn't show you how to integrate with respect to the y-axis. Okay. So that's why I included this. So x, notice how these functions are defined by x. So x equals 10 is this vertical line here. This is that function sine x, x equals sine y. Okay, basically it's the arc sine switched, but we don't really care about that. They told us, they gave us the graph, which is nice. If they didn't give you the graph, you could throw that into Desmos and Desmos would graph it. So what have I got going on here? Well, remember how the area is between two curves is, let's see here. Let me get a pen going here. Actually, let me get a highlighter going. So now what I'm doing is I'm going this way, and you see how the area that I'm looking for is in between those two curves. I know it's a line, it's a curve, right? A curve with degree 0. So what I've got here is I've got 10 minus sine y. That's that distance, that gray distance, those red lines that I put in there. And then when I integrate that from 0 until pi, and then dy, because they're going the y-axis. Now, if you scroll down and take a look at these MyOpen Math questions, you're not going to see the answers. You're not going to see, here, let me erase some of this so we can see this better. You see how I don't have that integral there. I see they have a 10 and a pi, but where the heck, I mean, and where that one, I mean, what are they doing? So here's what they did. Remember how we can break, when we're doing an integration, we can break, and we're having the sum or difference of two functions, we can break it out into two functions. So 0 to pi of 10 dy minus, that negative 1 is just a constant multiple of sine y dy. And then you can kind of see it's one of these two, and that's negative, so maybe that's it. Let's make sure, what if, just in case it's a not here, what's the antiderivative of 10 dy? Isn't that 10y? And then we're going to evaluate that from 0 to pi. So that gives me 10 times pi minus 10 times 0, which is 0. And then, so now you see how it's choice 1, and that's where that 10 pi came from. Okay, so great, be able to think about this way. I wish I had another couple of weeks. I would have you be doing more of these and with volumes and everything. And it's more interesting. You're going to get to go do that in Calc 2 and say, oh wow, this is a much better course. Yes, in ways it is. So you're starting to use some of this. So that's that question.